Yep. So I was talking about the last week, whatever we discussed, it was uncertainty in AI, and its world is full of uncertain events. So you need to also make those kind of assumption and conditions in your making your autonomous or AI based model. So in order to formulate this kind of uncertainty, we use a powerful tool called probability. Probability is a way to encapsulate incorporate this kind of uncertainty. For example, whether today rain whether it will rain or not. So I can say, yeah, it will rain with the probability, let's say 0.9, but still there is a chance it may not rain, and the probability of not being rain is 0.1. So this is kind of uncertainty we encapsulated here. So if you are saying whether it will rain or not rain, there must be some decision that has to make over it. So if you also consider uncertainty, then you can better consider those scenario as well, and model things accordingly. I have to go back and forth because of the internet, and it might be because of this, right? So last week we discussed what is the Bayesian network. So Bayesian network is a probability graph network. If you see PGN network, here you have something and you draw something like a decision tree. It's way to express joint distribution, joint probability distribution. Whether it's a cloudy, then there is a chance it will rain, there is a chance it is a sprinkler with some probability 0.5, 0.5. If it is raining, and then you have this joint probability, C means cloudy, true or false, and R equals to true means it will rain, R equals to false means it will not rain. So this 0.8 entry means that it is this is not cloudy, because if you see it is false, and rain equals to false. It is not cloudy and not going to rain, and its probability is 0.8, and it's quite obvious. So this kind of problem you may have to make it. So there would be a paragraph given the situation, and you need to draw it into form of a decision like that, and then you have to write conditional joint probability distribution. So if I'm here at rain, the only my influence occurrence will get influenced by my parent, cloudy. It has nothing to do with a sprinkler. So you just assume that you are calculating something about rain, then you just consider what is the probability distribution of cloudy. That will make into account. For example, for wet glass, both things will matter, sprinkler and rain, because nodes are coming from both sides. So there was one problem, very classical problem, and this kind of problem used to come in exams. So it was like that. Exam label, a task of modeling students' marks for an exam. So there would be an exam label. It will be easy with 0 means it will be easy and 1 means hard. So exam label would be easy with the probability of 0.7. It would be hard with the probability of 0.3. If it would, then it goes to marks. Marks would be 0 means less and 1 means high. So marks depends on two factors: what is the exam level and what is the IQ factor of that guy. So that's why there is two nodes coming from exams. And so marks, if you see, two nodes are coming, one from IQ level and another from exam level. And this is a joint distribution. Joint distribution means if you are talking about three events, then you just plot the distribution, how their occurrence happen. For example, this entry I1 E0 means IQ of the guy is high because it is 1, and E0 means exam level is easy. M0 is 0.5 means the student will get less marks, probability is 0.5. The student will get high marks, probability is 0.5. So like that you have to write joint distribution. For example, for admission you have to write joint distribution. You have to admission is your main concern, so you put it into your column A0 and A1. Admission will happen or not happen. 1 means happen and 0 means it will not happen. And from where the node is coming, from marks there is a node coming, so right, so you put it into rows. M0 means low marks, M1 means high marks. So like that you have to write a table. This is known as a joint priority distribution. For marks, why there were two things, I0 and E0, because there were two nodes coming, right, one from exam level, another from IQ level. That's why it is two, you know, tuples. The two entities are there in the tuple I and E. If someone will ask a question like that, calculate the priority distribution, priority that in spite of exam level being difficult, the student having a low IQ and a low aptitude score managed to pass the exam and secure the admission. This is the this kind of question will be given to you, how you know attempt this question. So there are 5 factors. If you see, A for admission, M for marks, I for IQ level, E for exam level, and S for your apti score. So we need to calculate probability that the student will get admission given this situation. The situation is exam level would be difficult, the student having a low IQ and a low aptitude score. These are the constraints, and we need to calculate what would be the probability that the student will manage to pass the exam and secure admission to the university. So if I have to write it into terms of numbers, A equals to 1 means admission will happen, M equals to 1 means will manage to get some marks, passing marks, and I equals to 0 because here it has said that IQ is low somewhere, right, having low IQ, that's why I equals to 0, and E equals to 1. E means your, what is E? E means exam level. Exam level was hard. Exam level was hard, and S equals to 0, that indicates that the score was low. So whatever they have said in the question, we just wrote it like that. Admission should happen, marks is high, admission should happen, constraints are marks should be high and IQ is low, and exam level is difficult, and S score, aptitude score is low aptitude score. So this is we have to calculate. So whenever you will get some question like that, please try to join before 7:10, otherwise I may not go back to the Google Meet and make you in. So by the next time, please keep this in mind. I have to go back and do that, make you in. It's becoming so much difficult for me. I cannot go back, so please try to join before 7:10. So question was like that. You will be given a question, calculate some priority distribution of about your final node. Here it was admission. So admission should happen, A equals to 1, marks should be high and IQ of the guy is less, and exam level is high and aptitude score is low. This is we have to calculate. So whenever you get some question, please try to enumerate. First step would be to write it in terms of 0 and 1. That is your first step. Once you are done with that, you just break it in terms of whatever here we have written. Admission should happen, it depends on what? It depends on only marks. So admission given marks. So you go just like a backtrack. Admission should happen given the marks, and for marks, what are the nodes? For marks there are 2 nodes, exam level and IQ level. So you enumerated like marks should be high given I and E. Now you consider also other thing. For example, here P of S, aptitude score, one node is coming from IQ. So P score should be high given I. I is your IQ score. And what are the independent nodes? If you see, these are the first nodes. It doesn't depend on anything. Exam level and IQ level. So you put it as P of I and P of E. That's all. So when you get question, write in terms of last node and then expand it. So which node depends on what? This is what you are getting from here. Now for the given question, we put the values here. Admission should happen, marks should be high. Marks should be high, but exam level, I is 0 means IQ of the guy is low and exam level is high. and I equals to 0 means IQ is obviously low, E equals to 1, exam level is high, score is low given IQ is low, right? That's all. This is one step you have to do, and then you have to just see the joint distribution table and put the values here. Admission should happen given marks should be high. What is the priority of that? Admission should happen. You see A of 1 given what constant? Marks is high, M is 1, so its priority is 0.1. I put it here into marks should be high given IQ is low and E is high. IQ is low, exam level is hard. Go to the marks table and see what does that mean. For marks should be high, M of 1, I0 and E1. I0 and E1, this is the value 0.1. I put it here again. For others, you also take the values from these tables and put it here, you will get some number, and the score is 0.0018. This is the probability that the student will get admitted even though exam was hard and the IQ of the student was low and the low aptitude score, right? Now coming to this was the premise for your Bayesian network. This is the classical problem of the Bayesian network. Bayesian networks are you are expressing your Bayes theorem or the conditional probability in terms of tree structure, in terms of probability graph structure, and this kind of question would come here. And now coming to the classical example what Professor Mawsam used to give. So it was you must have check this lecture. So just to give you overview, it was like alarm will happen, alarm will get sound, someone will call, there were two guys I guess, John and Mary, and then for about your home, about your room, it is burglary has happened. So these are the two your alarm will happen given the two conditions, either some thief has went there or earthquake has happened. If alarm will happen, then John will call or Mary will call. But Mary or John will call doesn't mean that there thief has been happened or something like that. So there's so much of constraint, and this is the real world where burglars can something disable the alarm. Maybe thief has come and they have disabled the alarm. This is one condition, and alarm will not happen, and still thief is inside your room. Some earthquake may be too slight to cause an alarm. Earthquake has happened, but it didn't cause alarm. So these are the real world scenario that can happen. You cannot go like this kind of deterministic thing. You also need to consider this kind of probabilistic model, and that's why we need to consider uncertainty, and that's why we are going here to model this uncertainty. Another example was back at the dentist. This is very simple problem. So you have cavity. You have cavity, right? And cavity may lead to toothache or catch. It has nothing to do with weather. That's why it is an independent node. So whether weather is bad or good, it has nothing to do with cavity. So whenever you get some question, you need to model it like that. Those are independent attributes. You make it separate, and those attributes which depends on other make a node here. Make an edge between previous to here. Now going in depth about sampling and all those things, let us go there. Yeah, so sampling should represent, sample should be representative of the world. If I tell you with this example, if you see how many people are more than 16 years old and they have master's degree. Sir, if you have time, kindly discuss the Q6 of the previous assignment. Yeah, so we'll discuss it. So as I said, I used to discuss the current week assignment first, and if I get time, I'll go back to that. So which assignment are you talking about? Which week? It's a probability uncertainty in AI or Bayesian network? assignment ends. Why didn't you join the last class? Did you join? And you can tell yourself, don't be in chat every time.
No, sir, I was absent during that session.
Okay, so if I get time at the end of session, I can go there.
Sure,
Otherwise,
sir.
you
Thank
may
you, sir.
mail me or the message.
Sure, thank you.
Thank you. So I was talking about sampling. So if I ask you how many people are, of age more than 60 years and have MS degree or let's say master's degree, there are a few possibility. You can see in your family, you may see in your class, someone may see in the whole area. So where you see, these are known as a space, these are known as a sample space where you're looking about that. So and you make your final decision based on that sample. If this question someone asks, I may check in my whole campus and say, okay, the priority is let's say 0.5. So I checked with the 10 people and of age greater than 60 years, and they said 5 of them said I have master's degree. But my sample space is very much narrow. It is in my whole IIT Patna campus. So if I'll go outside the campus, the numbers will not be 0.5. It will be much less than that. So it become biased towards this this area. So this is what sampling means. Sample, please try to understand these terms, which is very important. Samples means where are you looking for? Where are you looking about your distribution? So this is known as sampling, and sampling has to lot of do with the bias. So if you do a sample don't represent the universal space effectively, it will lead to some biasness. So these are the theories which you might have read in your things. I'll go quickly about the questions because most of the people are interested about the questions and all those things. But these things are very important. I remember last class people were asking questions and you don't know about the fundamentals of the priority. So that's why I have to go, and otherwise whenever I'll discuss the question, I have to discuss the theory first. So that's why the questions which are based on those concepts need to be discussed, otherwise you cannot go there. So parameter estimation, I was talking about. So this please try to take this equation, this line quite seriously. Think about that. So how you make model? We have data, we make model and do queries. This is known as the inference as well. So your model is dependent on data itself. So how you fit your data, your model will be just representation of that. And in runtime you can give the queries and it will give you the behavior what it has learned through data. And the key idea, if you go introspect deeply, it's just a counting. With temperature 23 degree, humidity A, whether it will rain or not, if someone will say 90% chance it will not rain. So it has been trained with some data, and data is nothing but a counting how many times with this temperature and humidity it has rained. Let's say 10 times out of 1000 times, so priority will be 10 by 1000. So just inside the model, nothing but a counting, and that counting depends on the data you are feeding. This is one example. Please take it there. There will be question at the end of the session, assignment similar to this one. So what is the question? Question is that the same problem which we took, earthquake and all. So it was earthquake and burglary. Oh, sorry, I am pronouncing wrongly. It's burglary, whatever. So earthquake will cause alarm, or maybe some thief will cause alarm. So here this is the scenario. E means earthquake, B means your burglary, and A means alarm. So these are the situations. 0 means there would not be earthquake, and 1 means there would be alarm. So this is the situation and this would be the number. If I'll ask this question, there in your assignment this kind of table will be given and ask what is the probability that this question, if I say there would not be E for alarm, what is the probability alarm will happen given there would not be earthquake, there would not be burglary. How will you go about that? Can anyone answer it why it's a 10 by 10, 1000 by 10, 1010? Okay, so you need to go to the, see, A means alarm is happening. Where is the alarm happening? You see the situation. Here alarm is happening, A is 1, here it is alarm is happening, and here it is alarm is happening, here it is alarm is happening, right? So situation here constraints are given, there will not be earthquake, there will not be any blurry. So you will have how much time, so it's alarm will happen given this situation. So this is the your area of interest, which is red marked here. 10 times alarm will happen given this situation, because situation is already given, E and B bar. E and B bar, you have these two rows, so it will be 1000 plus 10, it will be 1010, 10 by 1010, which will be around something 1 by 100, something similar to that. One important concept was to here illustrate about the smoothing. If you see this row, there is something 0, so when you are considering this point, you will have something 0 by something, right? But making probability to 0 or probability to 1, it's not the way. No, it may not happen, maybe because of your sample space you have taken in such a way that there is no chance, and that's why it is 0. For example, if I say this situation, it is saying earthquake will happen, blurry will happen, and alarm will not happen, right? So you have very less number of such samples. Your sample is quite biased towards this kind of scenario. It's very difficult. Earthquake will happen, I will go and check out whether alarm has happened or not. So your sample space is not true representation of such scenario. So in order to make avoid the scenario, you do smoothing. What does that smoothing mean? It means that you add something to this number, you hypothesize whether things will happen or not. Let's assume every time you add 1 to everyone, you assume that scenario. Maybe my sample space is not the best representation of the universal thing, so why not to assume that this is known as a prior. You assume this thing that okay, fine, this kind of scenario, let's say very rare, so you take +1 for those scenario. As I was talking about, this is the smoothing. So to deal with the event with the 0 times, you add something. For example, those who know dialog generation, so there might be something coming in testing time, which in training time model has never seen. So this kind of situation may happen. How to solve this problem? You can add 1, just add 1 to all frequency count. This is the simplest solution, Laplace smoothing it is known as. If you add 1, as you see, all frequency you just did add 1, you will have this number, and if you calculate this distribution, which will be quite close to whatever you had earlier. It was 1, but it become now 0.86, and others was similar to that, 0.2, 0.83, 0.2, 0.83 and 0.01. It's very close to this one, whatever we have. Now coming to a very important concept known as the maximum likelihood. So maximum likelihood is is very important concept in machine learning. Particularly when you train a model, you find out a parameter that maximizes the probability of seeing the data. You have data D, you want to get theta, so that whatever you have inference model or your validation model, that maximizes true distribution. So finally you given the theta, the model parameter theta, can you regenerate the data whatever it has been trained with? So this is what you try to make, get some theta which will able to regenerate a data. So you can think, okay, whatever model I had, it was true representation of data, because it can regenerate the data itself. So it has understood the data quite well. This is known as the maximum likelihood, and this we'll do. In last lecture, if you remember, I discussed this is a very important equation. That's why I'm going back to this equation. Yep. So this is what you had, right? Your data is evidence. Now you want something theta. So given data D, you want to have some distribution theta. This is the machine learning model. You have model M, you put data D, and you want theta, the network parameter or the model parameter theta, so that it can mimic the behavior what is inside the data. And it has been, here just Bayes theorem, P of d given theta and P of theta by a P of t. So anyone have any question in between, may feel free to ask. Bayesian network I talked about. So there is another concept known as MAP, maximum a priori. It's quite similar to ML, but the thing is here you take some assumption here. In MAP you have some assumption and you model that thing as well. So this is P of theta is your assumption. For example, if I give you, I am tossing a coin and 80% times, 80 out of 100 times it become head. If I ask you what is the probability of head, will you say it's 0.8 or will you say very close to 0.5? As if the coin is not biased, it will be always close to 0.5, right? So that assumption, if you also model it here in terms of P of theta, if you see this is the prior assumption, you are putting it here. So then it will be maximum a posterior estimate. You are doing some estimate of the posterior given you have some prior information, particularly about just example whatever I gave before the coin tossing. Okay, so a full Bayesian just illustration. You have h number of hypotheses, and you make your Bayesian tree or the Bayesian network based on all these hypotheses. This is known as a full Bayesian learning. You might have learned. This is one example, and there will be question based on that as well. So you will have this kind of bundles, red balls, red and green balls, like that. So these are the hypotheses. Also they have given 10% are H1, 20% are H2. These boxes are known as a here hypothesis, H1, H2 and H5. They are represented through hypothesis. I'll give you a box and I'll tell you to take one ball. So you have taken it, let's say it's red. There will be two questions: what kind of bag it was, whether it was H1, H2, H3, H4 or H5. This will be the first question, and second will be what flavor will be the next candy be. You took it one and then it was, let's say, red. Next time what it would be, whether it's a red or green. So these are the two questions. One is known as what kind of bag it is. It is a learning. Learning means you have finally trying to identify which bag it is with the given this data, this. And inference is if you know which kind of bag it is with some confidence, right? Because you will have some, you cannot do deterministically. Then if someone will ask what flavor will be the next candy, then you can, with this given assumption what kind of bag it was, you can say the most likely the board would be green or red. So this is known as inference. Try to understand this question. So it was 10% are H1, means whatever the bag you are going to get, there are these are the likely events. 10% might be H1, 20% H2, 40% H3 and 20% and 10% again this one. So most likely event is that you will get this kind of bags. Cherry and candy and lime candy they are calling. Cherry for red and the lime for green one. And this 10% cherry candy, what's saying, obviously it should be clear because all are red here. In H2 they are calling 1, 2, 3, 4, 5, 6, 6 out of 8 here. It was 75% of the cherry and 25% of the lime. 2 out of how much? 3, 3, 6. 2 out of 8, so it would be 25%. So lime candies are 25%. Sorry, I got disconnected. Can someone please confirm my slide is visible and I am audible?
Slide is not visible, but you are audible.
Oh really? Slide is not visible. One second. Let me reshare. I'm just refreshing the screen, so please be there. Please pardon me for this internet connection. It's too much fluctuating today. Is it visible now? The current slide example. Okay. Thank you, Krishna. Yeah, so here if you see, okay, so my screen is visible, I am audible, so I can just go over the slides and discuss the problems I put it for previous few years. So as I said, if you will have this kind of problem, how will you go about that? So this is, before going to the solution, let me discuss the problem a bit thoroughly. So I'm going to give you a bag, and I'll ask you to take one candy out of it, and then I'll ask which bag you are most likely to have and which candy is going to be next. These two questions I'm going to ask. So in order to identify which kind of bag you have kind of some learning procedure, right? So there are if you see 5 bags, and these are the distribution over it. In order to have, then we observe the candies drawn from the some bag is like that. All are line candies. How your priority distribution look like? See if you're here, see it thoroughly. So these are the different hypotheses. Red one is your first hypothesis, which is saying that this box would be there. This will never happen, because every time you are, if this going to happen, it would be red, right? But all the time it is green, so you are quite sure this is not going to the bag. So that's why from itself it is becoming 0. Initially there was a chance, but once you saw the observation, it was green, it becomes 0. This is how it look like. Similarly, for if you see for the green one, which is H2, most of them are here red one, only 2 are from green. So this distribution also quite low. These are the numbers you calculate. It's not for others. If this one, if you see this H5, all are green. So over the time, if you see first time you see green, okay, you are quite sure this is not going to be first bag, but it can be any of this one. But second time when you see there is again green, then you are likely to have you will have either this or this bag. But over the time, if you are saying if you are all going to be green, then You can assume, okay, so this the last bag was the priority that it has been picked. So over the time its priority is becoming increasing, whereas for others it is decreasing. As you see your observation, your priority distribution for others, getting decrease and increase over the time depending on the observation. Here the observation is green balls, or I'm calling it as a green ball, sorry, it's lime candies. So I have now a bunch of problems. I am not going to solve it first. I'll try to see if anyone can solve it, then otherwise I'll solve it. So this is one example from this was a situation. You must have seen in machine learning, you have data, but there are also some missing values problems. For example, if I have AB are the two dependent variable and AB are independent variable and C is the dependent variable. So your data look like ABC and 100 rows. So and C is your 0 or 1 depending on the values of A and B, right? So there might be situation where some values are missing. So here if you see, this is for B, it is missing. So how can you rough estimate what would be the B and then finally make the model over it? This is how you go about it. So it's becoming more of a egg chicken problem. You make data over your model, but your data is insufficient first. So you take some assumption about data. You have data D dash, let's say, and based on the D dash you make a model M, and with the model information you update the whatever missing values were, because you have some model. So with that model you estimate what were the missing value, you updated it, then go back and make again a new model M dash and go like that. So it's like expect something and then maximize with that expectation. Go and EM, this is why it's known as expectation maximization. You expect something, you have some expectation about this missing value, you make a model M over it, and based on that model you again hypothesize about that the missing value and make model again. You go and fro like that until unless whatever you have hypothesized model is also giving very similar value, then you can say the algorithm has converged. Expectation maximization is a very important concept in machine learning, in AI, so please take it very seriously. So first we need to take how can we fill this value, what would be the P of B. Let's see, can anyone say how can we fill this? Just random thought, any idea how can we go about it? Okay, so let me tell how you can think about it. So let's assume you have this kind of thing, P of B given A, it is 0, P of C given B, it is 0, and these numbers will be given. These are the initialization, right? P of A is 0.75 because 3 ones are there out of 4, so it will be 3 by 4, which will be 0.75. Similarly, why P of C given B is 0, so it's a condition priority and which is equivalent to P of C intersection B by of P of B, right? How many times C is 1 and B is 1 together? You see how many times C is 1 and B is also 1. Yeah, this thing, if you see P of C given B, which will be P of C intersection B by of P of B with the condition priority, right? So you forget about this last row. You assume this is nothing there because we have finally calculated with the algorithm it would be 0, but currently you assume there is nothing like that. There is no 0, it's blank only. So per P of A it would be 3, 1 given 4, so it would be 0.75. This is the initialization state. This would be given in your question, or you can calculate with the data. Now what is the priority that whatever the missing it was, it would be 1. Let's assume whatever the missing value is, it was 1. What is the priority? It would be 1. It is like P of B given A and C. I'm assuming it would be 1 given this scenario. What is the information about that this row is that A is 1, so that's why A, and C is 0, that's why negation of C. So given A 1 and C 0, what is the probability? P would be 1. This is how it has been done. Now you expand it using conditional probability, like whatever you have, P of A given B is P of A intersection B. So all three should occur together, P of A, B and negation of C by of, this is your evidence, P of A negation of C. So how many times A is 1, B is 1 and C is 0? A is 1, B is 1 and C is 0. No, there is no such evidence. So it is 0. So probability of being 1, it is 0. So that's why it would not be 1, it would be 0. So that's why you put it at 0. But this is just a hypothesis we are calculating with the data. So this was the expectation step. Now you do M step. M is the maximization. Now you make your model. So you have now this data and you calculate P of B given A. What would be P of B given A? Means B should be 1 given A should be 1. B should be 1 given A is 1. So these are the situation. 3 times here if you see A is 1, but only 1 times out of it B is 1. So it would be 1 by 3, which would be 0.33. Similarly, you calculate all the values and again you calculate this value P of what is the probability that whatever you have put it here, it is not 0, it's 1. If you calculate with this formula, you will get again 0. So you can assume whatever you hypothesize, it's correct and it is converged here very easily, because the example has been taken in such a way that it should be done easily. So expectation maximization step, if you have to do, make it like that. First step would be your expectation. You take some hypothesis about that missing value, you calculate with the initialization, and then make model over it. Now one step has been done. I have taken some hypothesis, I make a model M. With that model M, you have some distribution. Now use it and then you again hypothesis about the missing value. Okay, I did it again. Now you make your model. I made it again a model, let's say M dash. With that model, I'm checking whether what is the missing value. If it is value giving very close to whatever I have hypothesized previously, then you can say okay, it is both are going to the same thing. So algorithm is converged. There you stop. So this is the expectation maximization step. You do some guessing, compute the probability distribution over the missing values, update the probability based on the whatever the guess value, your model, right, and repeat until it converges. And it will guarantee to converge at least to the local optima. And now few questions we'll do based on the previous concepts that we have discussed. So till there, any question, any doubt, any remark? Okay, no, let's go over it. So this is one Bayesian network you have given. If you see, A goes to D, A goes to C, C goes to E, D goes to E, and C is dependent on B. So one golden rule I told you, whenever you have to think about one node, let's say I have to think about C. So I'll have to think about C, then I'll see a probability distribution about A and B. I'll not care about what has happened with the D and what has happened with the E. Only I'll see what are the parent nodes of this thing. So you please take care in this mind. So here the question is like, which of the following are true about the above Bayesian network? This is the network given and asked. These are the 4 options. C is the conditionally independent of D given A. C is conditionally independent of D given E. B is conditionally independent of A given C. And B is conditionally independent of C given A. Which one would be correct? Can anyone please try to attempt it, and then I'll clarify whether it's correct or wrong, or why correct or not. So we are talking about C if you see. So C depends on what? It depends on A and B. It has nothing to do with D and E. So whatever it was, C is conditionally independent of D given E. No, C has nothing to do with E. Why it will be well considered information about E. So this is not going to do. C is conditionally independent of D. C is conditionally independent of D given A. Yeah, that's true. If I know something about my parents A, I have nothing to do with those who are not in the upper node or the ancestor, right? So this first option would be correct. Second, we said no, it will not. B is a conditionally independent of A. Yeah, B has nothing to do with A given C, but C is also not parent of B, so nothing to do with that. B is conditionally independent of C given A. No, B has nothing to do with A, so the only option would be C is conditionally independent of D given A. Any question, any doubt here? Okay, fine. So again, one question similar to the previous one only. Given C and D, you have some information about C and D, right? E is independent of which of the following variables? You have information about C and D. E is independent of which of the following variables? So this is your point of interest, right? This E. They are saying E is independent of what variables if you have information about C and D? Whether it's independent of A or whether it's independent of B, whether it's independent of both or neither of A and B. This you people should answer. This. I told you in the initial slides itself how one nodes depend on other, if and only if there were some constraints, right? Okay, someone has written something, both A and B. Krishna Kumari. Yeah, it's true. It would be dependent on both A and B. That's correct answer. Because if you are here, your parents are only D and C, right? It has nothing to do with both A and B. So the answer would be, it would be independent of both A and B. Any doubt? Any question about this one? If I'll ask same thing about C, on which let's say about D. D depends on what? D depends only on A. It has nothing to do with E, C and B. It will be independent of that. If I'll ask about A is a static node. It has nothing to do with any other node. So just one follow-up question I was thinking about: if your nodes have lot of in nodes, in edges, modeling that node, is it difficult? Is it complex? Or would there be a lot of constraint over that node compared to a node where only one edge is coming, let's say? You must have understood, idea about in degree, out degree, something like that. So I was thinking, what is the correlation of in degree in terms of their priority distribution? Out degree is large, means it is causing lot of effects. In degree is large, means it is effect of lot of things. So when you are at the top of a Bayesian tree or the Bayesian network, most likely the node will cause lot of effects rather than leading to lot of effects. This is very important concept. So this kind of true false question also may come in your end exam. Your end exam would be on April 28, I guess. Just about one more month. So can anyone please confirm this assignment which I am discussing, its due date is over?
Yes, sir. It's over.
Okay. So this is one other question. Which of the following statements are true about the Bayesian network? The first one is the Bayesian network can be used to find out number of satisfying assignments for the Boolean formula. Inference in a Bayesian network always has exponential time complexity, irrespective of structure. Inference in a Bayesian network may be polynomial time for a certain structure of the network. Cutsets can simplify the inference in the Bayesian network. So all are true other than this Bayesian, a network always has exponential. Why it would be have always exponential time? You are already irrespective of structure. It has lot of things to do with the structure. If it structure is very much shallow, it's only two edges and something like that, then obviously it cannot be an exponential. So if this statement is not given irrespective of structure, then it may not be true. So given the statement, it would be false here. And this is one another question. Consider the following joint probability matrix. This kind of matrix will be given for x and y. Each row contains a value of x and each column contains a value of these are the y. Columns are y and x are, these are the rows 0, 1, 2. It has asked what is the value of p of y is equals to 2, x is equals to 2. Can someone please calculate? You all please try to first attempt and solve it, and then I'll do. This is pretty easy question, just conditional probability you have to see. And this kind of question, this table, it's a joint probability. So whenever you see Bayesian network in right hand side, you are seeing this kind of tables. Yep.
It's p of x and y divided by p of x.
Okay, let's do it. Yeah, so it would be p of x
And y
x and y divided
by p of x.
p of x, right? What should I do? What would be these numbers?
0.06.
0.06.
So 0.1 plus 0.05 plus 0.06.
0.1 plus 0.05 plus 0.06. Is it right? So it would be 0.06 by 0. How much it would be?
.29.
0.21. If you divide it, it would be something.
Oh, 0.29 after rounding off.
No, means this sum, this one. 1.5 and then 0.6, it would be 0.21, and if you divide it, then it would be 0.06 divided by 0.21, it would be
0.28571.
0.2857. Yeah, this would be the number. So everyone got it how we did it. So it's like a p of y equals to 2, x equals to 2. It's just a condition probability p of a given b, which is the intersection of p of a b and y of p of b, where p of b is your evidence that x equals to 2. So we write it like that. P of x and y means both should be 2, x equals to 2 and y equals to 2. I could have written like that, x equals to 2 and y equals to 2, and then probability of x equals to 2. So what is the probability that both x and y is 2? So this is the column, this is here 0.06, x is also 2 and y is also 2, so 0.06 here. I wrote it 0.06, and p of x equals to 2. What is the probability that x equals to 2? So this is the in row where we should consider. So x would be 2. This is the probability. 0.1 when y is equals to 0, 0.05 when y equals to 1, and y equals to 2, 0.06. So these are the chances which shows that x could be 2. So we just sum it up, 0.1, 0.05, 0.06, which should be 0.21, and when we divide 0.06 to 0.2, it will come around something like that. Is it clear to everybody? Okay, so let's go to the other question. Yeah, so what facts are true about smoothing? Smoothing is a very important concept when you do the machine learning algorithms. You'll find out what are its usefulness, why we just do +1, and it will save you from a lot of burden and a lot of uncircumstances where it may be lead to some infinity number, something like that. That's why we do smoothing. If your denominator would be sometimes 0, then it would lead to infinite number, and there you will have the problem. So in order to avoid such situation, you do smoothing. You do +1 to the each frequency. So here it is asking what facts are true about smoothing. Smooth estimates of the probability fit the evidence better than the unsmooth estimate. No, there is nothing like that. If you do smoothing, your model will be better. This is meaning of the first statement given the data. Second is saying the process of smoothing can be viewed as imposing a prior distribution over the set of parameters. Yeah, true, because we are saying the situation hasn't happened, but we hypothesize in the rare cases we assume that it would be 0, but we assume no, it would not be 0, it would be, let's say, 1. We are doing +1 to the each event. So this is the prior distribution we are putting, imposing a prior distribution over the set of parameters. Smoothing allows us to account for data which was not seen in the evidence. Nothing to do with smoothing. It is saying that the data which you haven't seen, it gives some evidence about that. No, not exactly. Smoothing is a form of regularization which prevent overfitting in Bayesian network. So here maybe few people have confused, and if you see just my probability guess, if this question has been given in your exam and 100 people have done, let's say 30 people have correctly marked, the process smoothing can be viewed as imposing the prior. 70% have marked incorrect question. Inside that 70, those who marked incorrectly, I believe 70% of failed attempt would be going here. Smoothing is a form of regularization of which prevent overfitting in the Bayesian network. So overfitting, what it means? Overfitting means someone is trying to join at this time, 8:20 V Maharaj. Is my screen visible?
Yes.
Yeah. So regularization means you are doing something to avoid overfitting. Now what is overfitting? Overfitting means you have data D You are making your model which will be too much constrained over that data. Whenever you will get something other than data, it will fail. So you are going too much over the data. It will not able to generalize the pattern. It will be lot of parameters and it will be, you know, perfect fit kind of things. So but not, here overfitting and smoothing is not related at all. Smoothing is to avoid zero frequency so that it will not lead either to, you know, infinite number, something like that. Now coming to this one, any question for this, you know, till these questions? I should mark it what it would be, both A and B, it would be independent of both. I may forgot. C is conditionally independent of D given A, that's true. So we are here, this question. Assume that we toss a biased coin with heads probability P 100 times. We get heads 66 times out of 100 times. So I had a one coin, I tossed it, you know, 100 times, and 66 times I got heads. If the maximum likelihood estimate of the parameter P is m by n, you have to do MLE, maximum likelihood estimation. Given the situation, 66 times you got head out of 100. So what would be m and n? And they're asking particularly this question, m plus n, what would be? Means you just find out the probability of MLE for the head, maximum likelihood, and you will, once you have m by n, you just do plus, and they're asking this number. So you people please try to do it, and then I'll do. Someone please say if you have come up with some solution to it. This is pretty simple, just new terms has been introduced MLE, otherwise it's not different. Okay, please anyone at least attempt and then say where they are wrong, and I can, you know, correct them. Yeah, please go ahead. Your voice is not clear.
I think m value is 66 and n value is 100.
Okay. So, yeah, Kanala, can you please mute yourself? It's currently. Kanala, please mute yourself. I may have to, remove it.
Hello.
Yeah, please say. Are you saying answer to this question? Hello. Yeah, who? Someone was answering the question. Please go ahead. Who? I forgot the name who was answering.
Yes, sir. I think the answer is 166.
Okay. So you are saying
Yeah,
what?
as m takes the value of 66 and n takes the value of 100.
Hmm?
Yes.
So you are saying
Then m plus n gives rise to 166.
Okay. So you are saying m plus n would be 166. Right. Anyone have anything to say about this? Anybody else? So whatever he said is correct, but he missed one point. So there it was where m and n don't have common factors. So this point he has missed. So if you see m by n, there is a common factor of 2. So you need to make it simplified, which would be 33 by 50. If you divide it by 2. Now they don't have any common factor. So m plus n would be
Yeah. Yes.
m plus n would be 83.
33 plus.
This would be
Can you
this.
repeat the calculation?
Yeah, sure. So question was, you'll have one coin. I'm tossing it 100 times and I got 66 times hits. So what is through MLE? It would be the chances of hit. So we 66 times we got hit out of 100, right? So this would be the number. But as the question said, I need m plus
then
n.
we simplified it.
It's at the 33 by 50 because they are saying they should not have a common factor. So m plus n would be your 83. Now come to the second question, the second part of this question itself. Assume we had a prior distribution. This is a prior distribution. This is the distribution. I'm giving